Welcome to Homework Lib.
Chapter 14, question 96. Consider two reactions. Reaction 1 has a constant half-life, whereas reaction 2 has a half-life that gets longer as the reaction proceeds. So what can we conclude about the rate laws for these 1 and 2 reactions? So we can think about this as we can just simply write the integrated rate laws to see what we're going to get. So for integrated rate law for first order reaction is going to be ln A0 divided by AT equals to KT. Normally this is a negative and this is flipped, but let's keep it this way. And the integrated rate law for the second one, AT equals to KT plus 1 over A0. So this is first and this is second. Now, if I want to find the half-life, then at the half-life, what we have is AT is half of A0. So if I write it over here, ln A0 divided by A0 over 2 equals to KT. So what we're going to get is ln A0's cancel. We have ln 2 divided by K equals to the half-life, T1 over 2. So this is a constant number, no matter what the A0 or AT are. But if we do the same over here, we're not going to get the same result. What we're going to get is AT is going to be A0 over 2, so I can write 2 over A0 minus 1 over A0 equals to KT. So we're going to have 1 over A0 and divided by K equals to T of the half-life. Now, if you look at these two equations, if I increase the A0, my T half-life will decrease. And whereas here, there's no change with the A0 at all. That is going to affect our T1 or 2. So if this second half-life gets longer as the reaction proceeds, I'm decreasing this A0. If I decrease, the half-life gets longer. If you want to graph these two, what you're going to get is this is concentration of A at time t versus time, whereas there's a steeper curve over here, concentration of A versus time. So these are, let's say these points are half-lives. As you can see, at first the half-life is just this much, and then it gets increased and then gets increased. Whereas here, it is kind of hard to visualize if I take these data points, but these intervals are all going to be the same. It's not going to change with the AT, whereas this, as AT, which A0 decreases, the half-life would increase.